This lesson again combines two previous lessons. We're going to graph quadratic inequalities. So we're going to use our ability to graph quadratic equations. Then we're simply shading. So these should be pretty easy to us. So we're going to create our table just like we did before. We're going to graph. We're going to use dotted lines and we're going to use solid lines, all depending on our symbol. Then we're going to shade either above or we're going to shade below, also depending on our symbol. So again, anytime you're dealing with a quadratic, I like to start out with negative b over 2a. I like to start out with our axis of symmetry. That would be a negative. Your b value is 2. Your a value is 1. So let's go ahead and start multiplying 2 times 1 as we plug it in. So our axis of symmetry is located at negative 1. Plug that value in to find your vertex. And again, we're plugging it into the equation. We're actually graphing y equals x squared plus 2x minus 2. So when you plug that negative 1 in, when we square it, gives us 1. We multiply 2 times negative 1 gives you a negative 2. So we get 1 minus 2, which would be a negative 3. So my vertex is located at negative 1, negative 3, which is right there. We're going to pick some values on each side of that to plug in. And again, if you use the stair steps, 0, 1, 2, I went up 1 each time. That would give us our symmetry to where we won't have to plug in the values on the other side. Plugging these values in, here's what you would get. And then taking and plotting the points, let's do that. And keeping in mind, again, if it's greater than, we're going to do a dotted line for greater. So our graph will look something like this, dotted on the other side. There we go. And if it's greater than, from any point, we're going to shade above that. Okay, so from these points, we're shading on this side, so we're shading on the inside of our parabola. Number 2, axis of symmetry, negative b over 2a. Our b value is 4, our a value is negative 1. So that'd be negative 4 over 2 times negative 1 would be negative 2. So our axis of symmetry is located at x equals 2. We plug in 2 for all of our x's. Reminder, negative x squared. Make sure that you square first and then take the negative. So when we plug in 2, we get 3. So that's going to be your vertex at 2, 3. Let's put a dot there. Let's pick some values on each side. 1, 0, negative 1, 3, 4, and 5. Doesn't matter if you go up on one side, down on the other. Let's plug those in. And there's what you get. Now let's take and plot all these points. Reminder also that since you have a negative x squared, negative 1 in front of your x squared, this should cup down. So plotting the points will show you that it does. And make sure you go back and fix this. I left my negative signs off right there. That would be negative 1, negative 6, so 3, 4, 5, 6, and then I'll have another point mirrored on that side. So there's all my points. Since I have or equal to, make sure let's do a solid line and not a dotted. And also, since it is less than, that means that I'm going to be shading below each point. So find a point and draw an arrow below it. We're going to shade to this side. So we're going to shade everything again inside of that parabola. Number 3. Start with your axis of symmetry, negative b over 2a. Your b value here is 18, so we have negative 18 over 2 times negative 3 would be negative 6. So you have an axis of symmetry at x equals 3. When you plug that in, it should give you 5. So 3, 5 is your vertex. 1, 2, 3, 1, 2, 3, 4, 5. Just by looking at this parabola should cup down. Let's pick some values on each side. 2, 1, 0, 4, 5, and 6. Again, they should mirror each other, so let's plug those in. Now, plotting those points will give you your parabola. Since your symbol is an or equal to symbol, make sure that you're going to draw a solid line instead of a dotted. And then finally, since this is a greater than symbol, from any dot, we're going to shade above. So therefore, we're going to shade everything on this side of your parabola, above every dot. So any point in this region out here should satisfy that inequality. Number 4, axis of symmetry, negative b over 2a. Your b value is missing. So since you have negative 0 on top, It doesn't matter what's on bottom, so 0 is going to be your axis of symmetry, x equals 0. When you plug that in, it gives you 6. So that's going to be 1, 2, 3, 4, 5, 0. 6 will be your vertex. Picking values on each side, -1, -2, -3, 1, 2, and 3. We'll give you values on each side of that axis of symmetry. As you plug them in, make sure again, there's no negative here, so just square it first, add 6 to it. And here's the values you should get. Let's plot those points. And you see there, it doesn't hardly fit on your graph. Since you have less than and no equal to, we're just going to dot or dash our line. And there's going to be my parabola. Since it is less than, we're going to shade below all these points. So we're shading on this side of the parabola. So your graph would look something to this effect. So your solutions would be any point that is in those regions. Okay, number 5. Axis of symmetry and vertex, negative b over 2a. Your b value here is -2, so that'd be -2. I'm going to go ahead and make that positive. 2 times a would be 2 times -2, which is -4. That doesn't divide, so we're going to reduce it. That'd be -1/2 is your x value. We've got to plug that in, and I'll show this one as I plug it in. I've got to square it, so it gives me -2 times, when you square a fraction, again, you can just square top and bottom. When you square a negative, negative times negative is a positive. So square the top, square the bottom, gives me 1/4. Minus, well, actually, it's a -2 times a -1/2, so that'd be a plus 2 times 1/2. I'll go ahead and write it. Now, to actually multiply these fractions, I would cross cancel. That's a 1 and a 2. So you now have -1 over 2. These cancel completely, and that gives you +1. -1/2 plus 1 is the same thing as a +1 minus a half, which is a +1/2. So my vertex is at -1/2, +1/2, which is right in the middle of that square. Go left a half a box and up a half a box. We're going to pick values on each side of that -1/2, which we could go -1 and 0. So let's go -1. And since, again, this is my strategy. Now, the more I think about it, well, we don't have fractions, so we don't have to worry about do we do even numbers and all that. So let's just do -1, -2, and -3 on one side. And again, 0 matches up with a -1, so 0, 1, and 2 on the other side. As we plug them in, here's what we get. Then let's actually plot those points. Let me erase that. -1, 0, well, that's odd that I actually had some dots there. And 0, 0. Plotting the rest of them, here's what we get. And the last two will not fit on my graph. Since it's or equal to, let's do a solid line connecting these dots. And since we have less than, we're going to shade below all of our dots. So we're going to shade the inside of that parabola. Now the last one, number 6. We do have to worry about the fractions here, so we are going to be picky about what we plug in. Our axis of symmetry, though, is -b over 2a. I like to say that formula over and over so it sticks. But b value is -4, so -4 is a 4. Over 2 times a, 2 times a half is going to be 1. So our axis of symmetry is located at 4. As we plug that in, and again, since we have a fraction, I'll show you my steps as I plug this in. Make sure with 1/2 x squared that you square it first, and then you multiply by 1/2. Again, multiplying by 1/2 is the same thing as taking half of it. So square the 16, or 4 gives you 16. Half of 16 is 8. Minus 4 times 4 would be -16, and then a plus 12. You can do 8 and 12 first. That's 20 minus 16, which is 4. So your vertex is going to be located at 4, 4. This should be an upward cut parabola. So we're not going to have much room to finish plotting this. But again, since I'm taking half of it, I like to think ahead and think, okay, what could I plug in for x so that when I take half of it, it gives me a nice clean number. When you square even numbers, it gives you even numbers. When you square odd numbers, you get odd numbers. So I wouldn't plug in 3 and 1 and all those because that's going to give you odd numbers when you square it, and it's not going to be as easy to take half of it. So what I would do is on one side, I would plug in values like 6, 8, and 10. some even numbers. On the other side, I would plug in 2, 0, and -2. And as we plug those in, here's what you would get. And oddly enough, those were actually pretty easy to plug in because look, since I have the same step, I'm going up 2, up 2, and up 2, then I should have a pattern over here as well. Okay. So what I did, let me go through what I did here to plug these in. I already had my 4. Okay, my 6, I went ahead and plugged it in. I noticed I got 6. Then I came down here and I said, well, you know what? I bet 0 would be easy to plug in because this would go to 0, this would go to 0. You'd have 0 plus 0 plus 12, which is 12. And if this is 12, this had to be 12. Then I said, okay, look for patterns. From 4 to 6, I added 2. From 6 to 12, I added 6. So if I went up 4 and I went up 4 again, that would be, I'm going to have to add 10, and that would give me a 22 there. So you can see the pattern, plus 2, plus 6, plus 10. And again, that pattern's always going to be evident when you have the same spacing over here. So let's plot those points, and I think that only a couple of the points are even going to fit. So let's go to, let's see, that's 4, 4, so 6, 6 will be here. Mirror image, you'll have another one here, and that's all that's going to fit. Since it's greater than, let's do a dotted line. Let's try to stay on the page. So a dotted line would look something like this. And then we're going to shade greater. So we're going to shade above the point. So we're going to shade inside of our parabola.